lecture we will start the hot runner system, है ना? So first of all, tell me what is the hot runner? Why we use the hot runner system?
Hot runner, like this is used for melting the screw bush. I mean the gate system for not having the runner or gate on the part actually.
Yeah, so basically, if we use this hot runner system, so basically the mold will not produce the feed system, right? So basically we will get the directly component, right? Okay. So basically this all the complete apparatus or the mechanism, you can say that we have to select, right? And because with this Aja, in previous lecture in previous lecture we have discussed about the mold which has a manual type of hot runner, right?
Hot runner we have
Semi hot runner. Yeah, we have discussed about the semi hot runner, which is like a Indian jugaad, you can say that, right? But that type of mold we cannot use, right? That type of mechanism we cannot use. So for this some type of companies, they are working on the hot runner apparatus, right? So we have to select from there, है ना? So basically, what is the function of the hot runner? Hot runner means it will keep the plastic into the liquid condition, right?
Yes, sir.
Okay. So basically, if we use the hot runner system, so basically mold will not produce the wastage. Mold will not produce the wastage, right? Here you can see that the element into the hot runner. See, what is the element which we will use into the hot runner? See, this is the connector box. What is the purpose of this connector box?
Sorry, maybe electrical wiring.
Yes, electrical wiring. Electrical wiring. Yeah. So basically, this connector will supply the electricity into this manifold, a complete manifold of the system, right?
Yes, sir.
Okay, and this is nothing but this is the top plate or the fixed plate, you can say that, right? Or this is nothing but this is the nozzle plate. Okay, and this all the system which is inside this box, okay, which is inside this box, this is known as manifold. So hot runner manifold, right? Okay, into the hot runner manifold we have to use this nozzle. We have to use this nozzle. Okay, now if I am talking about the material required to make the hot tip or the hot runner, generally use P20 for the manifold for the P20, right? P20 for the manifold generally we use, and H13 for the nozzle. But as I told you, depending upon the company specification or the company catalog, so basically they can use their material, but they will provide the efficiency for the nozzle or for the manifold also, right? So we can prepare, in other words, if I am telling you that we can prepare this manifold itself, we can prepare this manifold because this is nothing but this is the plate in which we have to implant this nozzle. So manifold we can create our housing, but it is quite difficult, but we can prepare, right? Okay, so but somehow, as I told you, but we should take from the company itself, right? We should not try to manufacturing this because there is a issue of the material, right? The thermal property of the material, right?
Yes, sir.
Okay, so that's why we should take the company systems, complete system from the company, right? Okay, so as I told you, the nozzle tip are usually made up of copper alloy, see here,
Okay.
to copper alloy, but also can be made from the S13 through the hardened of the life, if I am talking about the insert, for example, this is the nozzle, right? So for the replica, I have to provide the complete insert for this.
Yes, sir.
This will be the insert. Like, so what will be the insert material? We have to use insert material H13. But for example, if this is I have to machine like this into the insert, right? Like this, I have to machine like this. So this machining is very difficult, right? So for that, in some time we cannot use the ADM machining here. Why? We cannot use the ADM machining sometime because why? Because ADM produce the heat, and because of this heat, this material or this portion can be brittle, can become brittle. So that's why during the operation of this of hot runner mold, it can develop the cracked.
Okay.
है ना? तो because that's why we have to avoid the EDM machining during the manufacturing of this insert.
Okay, okay, sir.
You should understood these things. Is it clear? Now see, as I told you about the nozzle, है ना? तो general rule, for example, if I am selecting the nozzle, so what is the criteria or what is the rules for the gate selection or the nozzle selection, है ना? For example, like अच्छा, how to decide the gate diameter? Tell me. For example, like pinpoint gating system. So how to decide the gate diameter? This in cold
Gate
runner,
diameter.
D equal to
N into
n into t. Yeah, n into t, or n is nothing
number of
but
cavity into thickness.
or n is the material constant.
Okay, 0.6, 0.7.
Yes, है ना? 0.6, 0.7, like depending upon the material viscosity or the property. And t, what is the t here?
Thickness of the plastic.
Thickness of the plastic, है ना? Which is the average wall thickness, right? Okay, so we can so basically we can calculate the diameter, है ना? We can calculate the diameter. So here, as a general rule of the gate should be approximately 75% of the wall section. 75% of the wall section. For example, if the wall thickness is about to 2 mm, so what will be the 75% of the 2 mm?
One is 1, another 1.5.
1.5, right? Okay, so we should take 1.5 diameter, है ना? So here you can see that this is the different type of styles available for the nozzle. See here, tip style 2, tip style 3, tip style 4. See here. Now depending upon the components, we have to use the styles. We have to use the style. See, for example, if we need some space, so we have to use this, है ना, depending upon the uses. So style 1, style 2, style 3 we can use, but here you can see that tip style 4, where we can use this type of style. For example, we have a component. See, we have a component like this, and customer said, sir, we don't want to mark at the top of the component, right? Then what we have to do? We have to prepare a runner, okay, and we will provide a edge gating, yeah. Or where will be the 1 minute? And where will be the position for the hot runner? See, this will be the position 1.
Okay.
This will be the 2, right? So basically material will be go like this. So as I told you, depending upon the requirement, we have to use the tip style. For example, if we need some space, then we have to use this 2 type of style 2, style 3. If we don't need space, we directly want to touch to the component 0.5 or 1 mm, right? So we can use style 1.
Okay.
Now here, see, you can see that this is the length. Now this length is, again, as I told you, depending upon the component geometry. Component geometry. For example, if the component geometry is like this, so we can use the minimum length, right or wrong? So there is no requirement of that. For example, if the component has a structure like this, okay, like this, okay. So I'm again, for example, like n component has this section again, like this section component has this section, okay. So I have to provide a 1 nozzle here, and second nozzle, for example, I have to provide here. Then I have to use the 50 mm also, and as well as 90 mm also, just for an example, right or wrong? Okay. So here like this, so as I told you, this is the selection procedure. Is it clear?
Yes, sir.
And this is the selection procedure. So we have to take the standard, this nozzle or the manifold, right? So this is the procedure. Here you can see that gate 1.5 or 2.5 is available. For example, if we get the D by the calculation, if we get the 2 mm, we have a bigger part, we have a big part, then we have to use a 2.5 mm diameter, right or wrong?
Yes, sir.
So basically this is the diameter which is available for the nozzle, right or wrong? Now as I told you, when we are while we are selecting the gate for the cold runner system, right? So as we discussed that gate selection is also depending upon the type of plastic to be molded, है ना? Now depending upon the plastic, and as I told you, depending upon the property of the material means viscosity, which is the main property.
Low viscosity, high viscous material.
Yes, and the thickness of the wall section to be injected. And if I'm talking about you the plastic and the geometry of the component means, for example, if we have a component like this, or we have a lots of feature into the component, then it means we have to use the hot runner there, right? But we have to use the multiple nozzle. See, for example, 1, 2, 3, 4, 5 I'm using. Let's just for example I'm using multiple, right or wrong? Multiple gating system.
Yes, sir.
Understood? है ना? So now see. तो manifold is available, है ना? So basically this is the common standard which I'm talking about you, right? है ना? This is the common. Okay? So like it is known as like drop 2 drop like I section, है ना? 4 drop like X section like this, है ना?
The placement of nozzles.
Yeah, placement. And a 4 drop like H. For example, we have to prepare the multi-cavity layout depending upon the manifold. है ना? So basically we have this PCD.
Yes.
As we discuss about the gear. Similarly, like we have a already PCD, so we can prepare the multi-cavity mold, but depending upon the manifold. है ना? So we have this space point to point, है ना? Like this. Right?
Okay, sir.
है ना? So we can use this. Okay. Now manufacturing stage, as I told you, है ना? So है ना? In initial, as I told you that manufacturing of this section, है ना? So that GD&T of this section is very important. Basically, while we are designing the insert for this section, है ना? Insert for this section, so basically this GD&T few symbols we should know about that, right? See, we need concentricity, है ना? Concentricity. We need perpendicularity, for example, like this, for the proper butting or the fitting, right?
Okay.
है ना? So this is very important, and this length is very important from this point to this point. So depending upon that, we have to decide the height, है ना? We have to decide the height, है ना? Then upper part of the which will be touching with the nozzle, which will be the manifold, right? See, this is the point. Read this point. We should avoid the EDM, cause the steel surface to harden and become brittle, which may lead to cracking or the failure of the gate system.
Okay, sir.
Okay, so that's why this is very important. No, this is very important points. Now see here, manifold, है ना? So basically, as I told you, we can design our manifold in house also, but we have to take the L1 or the L2 length should be equal. You can say that this L1 or L2 or the R1 or R2 should be equal, like as I show you this distance, right?
Yes, spacing should be balanced.
Spacing should be uniform. You can say that, right?
Uniform.
Yes, है ना? So this is very important. So as this see here, good manifold layout, all the are equal length, giving the balanced design. See here,
Balanced.
है ना? हाँ, तो और this is the poor manifold layout. This is not providing the balancing, right? Okay. Now see here. Now what is this? Now you can see here. This is the manifold, right? This is the manifold, है ना? So from the manifold to the top plate, there is this button like this, है ना? See. So this button or the rest button, you can say that this is providing a space between both, right?
Okay.
Why? What is the reason of that?
No, uniform 0 butting, for that you can grind that point whenever you want to assemble properly. Like
Yeah, and one more reason is that heat dissipation. Heat
dissipation is heat does not want to go out, or like what, sir?
Basically, if I'm talking about this, see here, this is the distance, right? See here. So this distance we have to maintain, which minimum 10 mm we have to take, है ना? From the cavity plate, or you can say that this is the nozzle plate, right? Okay, from the nozzle plate to the manifold. So 10 mm distance we have to maintain.
Okay.
So what is the reason? Because if the manifold will be in hot condition, right?
Yes, sir.
So basically, if this hot manifold will be touched with this plate, then it will transfer the heat to the this plate, right?
Yes.
So because of that, some problem may be occur into that, right?
Okay, sir, but how much temperature would you expect in hot runner, sir? Maximum, like how much it will go maximum?
Depending upon the material, like for example, like material like PP. What is the
Consider
melting?
for PP or ABS something.
Yes. Like for example, we are using PP. So what is the melting temperature for the PP?
I mean, like melt temperature.
Yeah, melt 160 to 170 degrees Celsius, है ना? Maybe this is the range depending upon the environment also, right? 160 degrees Celsius to 170 degrees Celsius. So basically this temperature we have to maintain, and this will have a control system also into the hot runner system, right?
Oh, okay, sir.
So that's why this is very important. So that's why, for example, if we heat more than 170 degree, so basically material property can be changed, right or wrong? So basically they will not produce the uniform component into that from that.
Yes, sir.
And this is very important. That's why we have to use the hot runner from the company. And so we have to select the manifold or nozzle or everything. So that's why, right?
Okay, sir.
So here this is the hot runner system. As I told you, this is nothing but this is the hot runner system which we have to select depending upon the which company we are using. For example, we have this catalog. Like for example, like see here.
Sherlock Holmes.
Yeah. So for example, like so we have to give the specification of that what type of nozzle or the what type of manifold we need, right? Depending upon that, see here. So into the catalog they provide all the dimensions. See, they provide all the dimensions which is required for the design engineer. See, and because they have to design, they have to manufacturing this insert, right? This insert and this, but these all the things provided by the company. See,
Sure.
this is all the parameters. See here, 1 minute. See, this is the very lengthy process basically for the design engineer. For example, if they are dealing with the hot runner, it means they should spend lots of time for designing that, right? And so see here 15 mm from this point to this point. Okay, so here you can see that. So we have to discuss. There is a team design for manufacturing of that type of hot runner, particular hot runner mold, right? See here. 0.0 minus 0.01 means 10 micron. See,
10 micron.
here 10 micron. See here, and here is, see, this is the length. See, okay, and here you can see that. See, right now, see.
Yes, sir.
So lots of things here. Here, for example, this point to this point, this is the 5 mm distance, right? So here see, we have to maintain this 0.2 radius maximum. This is the 0.2. So basically we have to give the clearance there. See here. See, you can see that. This is the, see. And this is all the specification. Depend. So we have to discuss about that also. We have to discuss all these things. Right? So basically this is the nozzles. This is the nozzle. Now if I am talking about the manifold, see. Now see manifold. Now see here. See, like this.
Just a small doubt.
Quite complex, right?
Yeah, but this thing, will they suggest this thing? I mean,
which thing?
I mean,
See, yes.
sir, what about manifold material, sir? What kind of material should we use?
So as I told you, they are using similar to the P20 material for the manifold, right?
Manifold.
Yeah, for the manifold. This is the manifold here. So this is the location for the No, sir. So as I told
Okay.
you, Vignesh, this is the complete selection procedure. Is it clear? Complete selection procedure. So basically, for example, we have prepared the complete mold for the for any type of component. So basically, we have to prepare the complete moving half portion first of all, right or wrong? है ना?
Yes, sir.
Then we have a component, like for example, like this. So we like this is the component we have. So basically, basically this complete portion, this complete portion will be the hot runner system, right?
Yes, sir.
Okay, complete. So
I mean,
basically,
fixed half will be the hard runner, moving off will be the another part, right?
the moving half will be the another part. Okay, this is
Another
provide the
part.
ejection. So
Fixed half.
basically, fixed half will be the hot runner system. See, है ना? See, this is the manifold, and depending upon the component. Now here, see, this is the H type of manifold. See, okay. See, here this is providing the distance from this point to this point. This is the L, which can be 100, 125 or the 150 mm, which is the standard depending on company norms, right? See,
Yes, sir.
है ना? See, है ना? This from this point to this point, this is the 75 distance. So depending upon that, we have to design our complete spacer and the top plate and the cavity plate, right?
Yes, sir.
है ना? So we have to design depending upon that. So this is all the complete. So there are lots of specification and length and the width and the number of cavities depending upon that. Lots of specification of the manifold and as well as the for the runner. So we have to select that. Na? We have to select that depending upon the component. Right or wrong?